The very last topic that I want to cover is the effects of nuclear radiation and our biology. And so, in taking a look at some of the biological effects of nuclear chemistry, an alpha particle. An alpha particle is easily stopped by your skin or a piece of paper or some other very thin piece of material. And so we are not at all concerned about alpha particles in terms of them hitting us from the outside. Now, if you were to swallow something that gives off alpha particles, that's a whole other story, because now the alpha particle is trapped inside your body and is not going to be able to get out. On the other hand, a beta particle is typically stopped by a thin piece of metal, but it will go through your hand, but is stopped by a small piece of metal. Gamma radiation, on the other hand, requires quite a lot of protection. You're not going to be protected by it. It goes through concrete walls. It's stopped by very thick lead. So unless you have a bomb shelter that's outlined in lead, you're not going to be stopped. You're not going to be stopping the gamma radiation. On the other hand, in terms of ionizing ability, and this is what we have to be concerned about, because some particles can ionize very easily. An alpha particle is 10 times better at ionizing your molecules, particularly water, than a beta particle is. And an alpha particle is 20 times better at ionizing than a gamma particle is. So even though a gamma particle is going to be able to go through concrete and go through you, the likelihood of it ionizing something in your body is far less than an alpha particle ionizing something in your body. And so this takes us to our units of measurement when talking about nuclear chemistry and our bodies. A rad, short for radiation, is equal to 0.01 joules per kilogram of tissue. The more common today unit is a sievert, which is 100 times bigger than a rad. But typically when you're taking a look at medical kinds of things, they look at rads. And so that's how much energy is absorbed by your tissue. And RBE stands for the relative biological effectiveness. And so here we saw that gamma rays were not particularly effective at ionizing your tissues. Alpha particles are much better at doing that, and so there's this idea that we can, X-rays and gamma rays are about equivalent to each other. They are less than beta particles. Those are less than neutrons. Those are less than alpha particles. But basically, these are going to measure the effects on biological tissues. Lastly, we come to the REM, which stands for the Roentgen equivalent for man, and that is equivalent to the rads, the number of rads that you're getting, times the RBE, times the relative biological effectiveness. And so when we take a look at how many REMs we can absorb and what kind of an effect those things have, this is in your textbook, and I've narrowed it down to maybe some of the more common ones. 0 to 5, there's really no effect that is observed. If you're getting 70 REMs, that is probably going to cause you to vomit. 75 REMs is going to cause hair loss. These are the kinds of things that you see when you are getting radiation treatment for cancer. If you are exposed to 100 REMs, you will start hemorrhaging. 400 REMs is possible death. 1,000 REMs, there will be death in about 1 to 2 weeks. And if you get hit with 2,000 REMs, you will die within hours. All right, so we'll come back to this page after looking at the next page here, which talks about the radiation source and how many millirems per year the average person is exposed to. So when we take a look at cosmic radiation, this is radiation at sea level, we get on average about 26 millirems per year. Again, that's at sea level. If you're up in Denver, Colorado, you're getting hit with about twice that amount, because you don't have as much of that radiation going through the atmosphere, right? You're a mile up, and so some of that radiation can get taken out by that mile of air between you and as high up as Denver would be. Terrestrial radiation, this is the radiation that is coming from uranium or plutonium or whatever might be in the earth, and we are exposed to that constantly, and that gives us about 29 milligrams per year. Radon is about 200 milligrams per year, and that really is going to depend on sort of where you live, how much time you spend in a basement kind of thing, whether your walls are made out of concrete or they're made out of stone, or whether they are made out of wood, right? So you're getting the radon from the decomposition of uranium and things of that sort, which are in your building materials, and so that's going to give about 200 milligrams per year. Lastly is the internal, and that might be due to potassium 40, which you eat. Bananas are full of potassium, right? But some of that potassium is going to be potassium 40, which is going to deteriorate or fall apart over time. Carbon 14, you're always breathing in carbon dioxide, and some of that carbon dioxide is going to have carbon 14 associated with it. So that gives us about 40 milligrams per year. So naturally, the radiation sources are giving us about 295 milligrams per year. When we take a look at some man-made kinds of things, or man-made causes of radiation, we are getting x-rays every once in a while. If you get a chest x-ray, that's going to give you about 15 milligrams. If you get a dental x-ray, it's about 200 milligrams. On average, we get about 39 milligrams per year. If you go to the dentist and you get 2 x-rays every year, well, that's going to give you 400 milligrams right there, right? Nuclear medicine, on average about 14. Now, if you don't take any nuclear medicine, then you are not going to get any of those milligrams per year. But if you have to have a thyroid diagnostic, that's going to cost you about 28 rems, and so you know that that's going to affect you, because 28 rems, right, is greater than 5. It's less than 70, but that is going to give you some difficulties there. There are some consumer products that we are constantly exposed to. TV, color TVs have nuclear kinds of things in them, and they are constantly giving off radiation. Smoke detectors have nuclear materials in them. Americium is one of them, and on average we're exposed to about 11 milligrams per year. And then there's some other kinds of things. Those other things might include nuclear fallout. It used to be 1963 was sort of the peak for nuclear fallout. We were getting about 10 milligrams per year from nuclear fallout in 1963. That has fallen over the years. We're now down to about 1 milligram per year from nuclear fallout. Power plants, air travel, obviously the closer you are further away from you get from the Earth, the more cosmic radiation you're getting. So air travel, actually, if you're in the air a lot, can give you quite a lot more radiation. Occupational kinds of hazards might give you some radiation. So all in all, on average, you're getting about 2 milligrams per year from all of that. When we take a look at the man-made or anthropogenic sources of nuclear causes of us getting radiation, that comes out to about 66 milligrams per year. So 66 milligrams, if we go back to our chart here, that's 0.066, or maybe about 0.1, if you will, rems per year. And so that falls easily into this category of no observed effects. Even the natural ones, we're looking at 0.3 rems, and so that really is not going to have an effect on us either. Smoking, on the other hand, smoking can add about 280 millirems per year, and that can be significant. That's for about a pack a day. So if you are a smoker, you are constantly exposing yourself into this area of radiation. And again, that isn't going to be causing you to be vomiting or causing you to have hair loss significantly, but it does have effects, and these effects can be cumulative. So if you're a smoker for 40 years, right, 280 times 40, it's about 12 REMs. It can start to add up over time. So that is the end of Chem 122. I hope the course was informative for you, and if you have any questions, don't hesitate to jump into office hours. Have a good rest of the week.